So again, my name is Chris Love. I'm with a company called 𝐷𝑒. We're actually associated with a company called 𝐓𝐡𝐞, who's one of the sponsors at this event. And we have some folks that work with us from 𝐓𝐡𝐞. So we're going to talk about evidently the past, the present, and the future of Kubernetes and big data. So this slide was actually when I asked you guys all the questions. And really what I wanted to talk to you about is how we have a significant issue right now with big data. So who works with big data here? Who does big data work, right? Who creates big data here? I don't see enough hands. Everybody needs to be raising their hands right now, because unless you don't use the internet, you actually create big data. So what we're talking about in terms of size is, since the beginning of time, man's created about 3 exabytes worth of data to about 2003. We're on track, and this was known for a few years ago, to create over 53 exabytes of data shortly in 2020. We're currently creating 2.5 quintillion bytes of data a day. That's quintillion has 18 zeros behind it. So needless to say, this amount of data is causing significant issues with both data scientists as well as big data platforms. Traditional platforms just cannot handle this amount of data. So one of the chief product officer of Cloudera, which is a new company, recently posted a blog article that talked about how Hadoop is dead. And he was saying, long live the king is dead. What he meant by that is that right now, the original way that we're using Hadoop, and Hadoop is one of the largest big data tools out there, doesn't work anymore. What he was basically saying is that it's dead, it's gone, it's dusted. The way that we approach big data right now is not the way that we have to approach it in the future, and the way that we're approaching big data right now actually isn't working very well. Estimated numbers that data scientists can access 60% of the data that they have right now. So, and of course, all the cloud providers want you to believe that managed services are the answer. And admittedly, services like EMR and data from AWS, as well as Dataproc, are really good services, and if you can use them, great. But what if your client's using Solar, for instance? What if your client's using Cassandra, for instance? There's no managed services that I know of that are good managed. Like, there are managed services out there. Find a Solar or a Flink managed service, it's probably a pretty hard thing to do. So, what options do you have as a developer or business owner? So, here's entering Kubernetes. And since the crowd is not too familiar with Kubernetes, I'll give you folks a little bit of an overview. Most everybody here has heard of Dockers and containers. Well, Dockers and containers create a whole unique set of problems on the run. And what Kubernetes does is it creates you a pool of nodes that you're able to deploy containers to. So those containers are able to have load balancing, fault tolerance, failover, all kinds of bells and whistles. I won't invest an incredible amount of time talking about Kubernetes. You can go look it up online and listen to some really good presentations about that as well. But really, to me, business, unfortunately, is all about time and money. And that's where Kubernetes can help you out. One of the big things with that Hadoop is getting is that it's not affordable, and other big data technologies is it's becoming significant money machine. Most of the time, most computers are sitting idle, specifically servers, in big data applications. They're about 60–70% actually now. With Kubernetes, you can address that by dynamically expanding or contracting your footprint, as well as you're able to have much higher density in your compute so that your workloads are very, very dense and you can efficiently use the platform. So let's go back in time. This is a bit about the past, the future, the present, and the future. So let's talk about the past in Kubernetes with big data. Yeah, it wasn't ready. Pretty simple. So let's start and talk about why it wasn't ready. Let's talk about a big data technology called Zookeeper. Zookeeper is used by a lot of Apache products. What it needs in order for it to run, it needs a stable hosting. So, if you have your Transformer hostings or you have your Star Trek hostings, they all have be the same, right? You can't start Zookeeper over here in Enterprise and then move the instance over to Define. It needs stable, persistent storage. It also needs orderly naming, and it also needs sequence startup and teardown. Zookeeper doesn't like, it can fail over, but it really doesn't like if you start instance 0, then start instance 3. It gets kind of confused. And it likes a lot better if you start instance 0, then 1, then 2, then 3. So Tim Hockman was also talking about a significant issue that Kubernetes had. Tim Hockman is one of the principal architects for Kubernetes on GKE. He's talking about how storage is hard. And realistically, storage is one of the hardest things in terms of big data and other systems. And so what he was talking about is that within Kubernetes, mounting and unmounting volumes is very challenging, as well as just creating stable, persistent storage. He was talking about that a couple years ago. So that's how I often looked using big data with Kubernetes before it was ready. I definitely did it myself. One of the fun stories was in Kubernetes 1.4 on AWS. Had about 4 clusters, and about 60 volumes across those clusters. And there's something in AWS called rate limiting. Anybody get rate limiting in AWS before? Yeah, it's not fun. Don't do it. Couldn't log into the account to give you an idea of how much Kubernetes messed up my AWS account. So let's talk about it now. We have this component called stateful sets that were created in Kubernetes 1.4, which came out a couple years ago, and now they're really stable and very much useful. Stateful sets give you the functionality. If you remember the Zookeeper slide that I had, give you the functionality that they require. Stable network identifiers, naming, and DNS. Also give you stable persistent storage. You're able to pair storage with a pod in Kubernetes. So if you have pod 0, the storage 0 will always mount to that pod. You've got graceful scaling as well as deployments and updates. So you're thinking now, great, Kubernetes is ready. It's easy. Well, it's getting easier. Storage as well has come a long way. There's an interface called CSI, which is the container storage interface. So it's getting a lot more robust, a lot more different storage types. But it's still pretty hard. And what I mean by that is that you don't just have to know Kubernetes, or you don't just have to know big data. You have to know both. I was chatting with 𝐁𝐢𝐠 �HighTower on Twitter and got these tweets off of him. 𝐁𝐢𝐠 �HighTower is a developer advocate for Google. Probably one of the predominant thought leaders in the Kubernetes cloud and serverless space. He's talking about how Kubernetes is not enough. It's not just about Kubernetes. And realistically, it isn't just about Kubernetes. It's about your deep understanding of Kubernetes, as well as your deep understanding of the database that you're trying to run. And not only is it a deep understanding of the database that you're trying to run, but it's also a deep understanding of running that database on top of Kubernetes, which is pretty challenging in itself. Also, we've got this big buzzword that's called cloud native. And what does cloud native really mean? What it means to me, at least, in terms of Kubernetes space, is that a database is able to run, or a big data store is able to run on top of Kubernetes. Well, guess what? Oracle? Yeah, I don't think I can get that to run on top of Kubernetes. Anything that can't go into a Docker container realistically cannot run in Kubernetes. More and more, there are good databases that are becoming more and more cloud native, and some have been built to be cloud native. We've got Elasticsearch, we've got Spark, Cassandra. Didn't put Hadoop on top of there because Hadoop's going to change in order to be big data ready. We definitely run all of these big data stores on top of Kubernetes successfully. But like I said, you need to understand your data store, and you need to have good knowledge of Kubernetes to do it. So let's talk about some use cases. We work with one of the world's largest retailer that's focused on crafts and vintage goods. They're running in production a very large system with solar and Elasticsearch. So when folks do your holiday shopping, you'll probably be hitting Kubernetes, running big data. Also, we work with a cyber defense company that's doing intrusion detection with Apache Think. and they are very successful at that. We work also with Amdocs. They're running Kafka for eventing. And all of these are happening on top of Kubernetes. But again, you have to really know what you're doing. So let's talk about the future. So hopefully we won't have to know much, and hopefully it'll be easier. Realistically, in my mind, everything's going to become cloud-native. Some of the founders of Kubernetes have estimated that Kubernetes is going to last for about 4 years. That would be in terms of Oracle database, VMware, other platforms that have that much longevity. And a lot of very large companies are putting a lot of money into Kubernetes. I can say, in my mind, that we will at least have Kubernetes, if not a successor, running for about 15 to 20 years in production from this point on, which is, in terms of software time, a very, very long time. So if a product isn't cloud ready, it's going to be cloud ready. If a product isn't supported on Kubernetes, we'll have operators and/or some other form of technology that will make a big data source supported on Kubernetes. Also, we're going to have new stuff, right? So one of the, there's definitely new startups. CockroachDB is one of them. For instance, RDMS, so relational databases, don't do real well on top of Kubernetes currently. There's lots of relational database startups that are specifically building databases for the cloud. Also, GPUs, CPUs, primarily used in machine learning right now. But my thought process is that we're going to need more CPU power, more disk power, and the way that we're going to do that, and some emerging databases are definitely using GPUs and CPUs for database access. Also, we're going to look at more and more machine learning, artificial intelligence. We're going to look at how quickly can we access data, and systems are going to have to understand what data we're going to have to access it before we need to access it. And the only way that we can do that is predictive modeling, machine learning, and of course, artificial intelligence. And of course, it's going to be easy, right? No. Unless we don't want jobs anymore, it's not going to be easy. But besides that, from my perspective, big data is always going to be a challenge for us. Yes, certain aspects may become easier. Components become more and more supported on top of Kubernetes. We'll get better and better managed services. But realistically, data scientists and other engineers are going to come up with, hey, this is really cool on how to do it this way because it solves a bunch of business problems. Guess what? Anything that's really cool usually isn't really easy. So I think this is still going to be a challenge for us for many, many years. The rate at which we're generating big data is huge. And but I'm looking forward to getting through the challenges as we go along. Thank you so much. Really appreciate you having me today.